Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on systems of linear equations and their solutions. In our last lesson, we learned how to solve linear equations in two variables. We learned that there are infinite solutions to these equations because for each value of y, there is one value of x. Today, we will study systems of two or more linear equations in two variables. Students, are you ready? Let us begin. I would like to start today's lesson with an activity. Consider these equations. Determine the values of y for each equation when the value of x is -1, 0, and 1. Write the values as ordered pairs.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. I hope you recalled how to solve these equations from our last lesson. For the equation 3y equals 1 minus x, the ordered pairs are -1 and 2 over 3, 0 and 1 over 3, and 1 and 0. For the equation 5y equals 2 minus 2x, the ordered pairs are -1 and 4 over 5, 0 and 2 over 5, and 1 and 0. Students, notice that if we were to plot the ordered pairs on an xy coordinate system, the lines would intersect at the point 1 and 0. This means that the ordered pair of 1 and 0 satisfies both equations. Therefore, it is the solution to the system of linear equations. A system of linear equations is a set of two or more linear equations. A system is represented as a1x plus b1y equals c1, and a2x plus b2y equals c2. As we just determined, a solution to a system of linear equations in two variables means the set of ordered pairs xy that satisfy both equations. Just as linear equations can have one solution, no solution, or infinite solutions, systems of linear equations can have one solution, no solution, or infinite solutions. If we solve two equations and find that they have no ordered pairs in common, then there is no solution to the system. Similarly, if we solve two equations and find that they have every pair in common, then there are infinite solutions to the system. Students, please copy down the following systems of equations. Determine whether each system has one solution, infinite solutions, or no solution. For this activity, we will use specific values for y of 0, 1, 2, and 3. You may begin, students.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. How did you do? Remember that we were able to solve these equations because we were given specific values for y. Let us look at the solutions together. To solve each system, we must solve each equation one by one. For 3x minus y equals 7, let us give some specific values for y, like 0, 1, 2, and 3. Then we will solve for x accordingly. Where y equals 0, the equation becomes 3x minus 7 equals 0, and the value of x is 7 over 3. Where y equals 1, x is 8 over 3. Where y equals 2, x is 3. Where y equals 3, x is 10 over 3. The ordered pairs for 3x minus y equals 7 are 7 over 3 and 0, 8 over 3 and 1, 3 and 2, and 10 over 3 and 3. Now we solve the second equation. For negative 3x plus 3y equals negative 1, where y equals 0, the equation becomes 3x minus 1 equals 0, and the value of x is 1 over 3. Where y equals 1, x is 4 over 3. Where y equals 2, x is 7 over 3. Where y equals 3, x is 10 over 3. The ordered pairs are 1 over 3 and 0, 4 over 3 and 1, 7 over 3 and 2, and 10 over 3 and 3. Since the ordered pair 10 over 3 and 3 satisfies both equations, there is one solution to this system of equations. Now let us look at the second system of equations. We will begin by solving negative 3x plus y equals 5. Where y equals 0, the equation becomes 5 plus 3x equals 0. And the value of x is negative 5 over 3. Where y equals 1, x is negative 4 over 3. Where y equals 2, x is negative 1. Where y equals 3, x is negative 2 over 3. The ordered pairs for negative 3x plus y equals 5 are negative 5 over 3 and 0. negative 4 over 3 and 1. Negative 1 and 2. And negative 2 over 3 and 3. Now we solve 3x minus y equals 5. Where y equals 0, the equation becomes 3x minus 5 equals 0, and the value of x is 5 over 3. Where y equals 1, x is 2. Where y equals 2, x is 7 over 3. Where y equals 3, x is 8 over 3. The ordered pairs for 3x minus y equals 5 are 5 over 3 and 0, 2 and 1, 7 over 3 and 2, 8 over 3 and 3. We have no ordered pairs in common. Therefore, there is no solution to this system of equations. Students, note that this method doesn't guarantee our conclusion because few values of y are considered. It may take a long time to get common ordered pairs. So, we need to use additional methods of solving systems of linear equations. In fact, students, if you were to graph the ordered pairs for that system of linear equations, you would find that the lines run parallel to each other. The lines will never intersect. Therefore, there is no solution. We will learn more about using this graphical method in our next lesson. Until then, thank you, teacher. Thank you, students.